Welcome to the Offshore Structures Tech Talk. My name is Geoff McDonald. Today we'll be talking about accelerated design efficiency across all offshore design phases. Offshore structures experience many different load combinations during the various phases of construction, installation, and operation. Multiple analyses are required to model all of these conditions, but when it comes to design, the critical load combination must be determined for each element. With SACS, this has traditionally been a manual process, which can take some time for users to check each individual analysis. With the Combined Results Database utility, each analysis results database, or PostView database, is combined into one PostView database containing all of the information of the component analyses. This PostView database can be viewed in Precede just like a normal PostView database, with some additional features to help view and manage the various component analyses. The SACS reports database output is used in the Combined Results database and is therefore required for each component database. The SQLite database output can be enabled by checking the SACS report database option in the analysis generator for each component analysis. Dissimilar models may be combined, which can be useful for combining analyses at different phases in the structure's design life. However, SACS will combine results based upon the member's joint-to-joint definition, so it is important to ensure that the same joint-to-joint definition of members are indeed the same member across all component analyses. The SQLite database output can be accessed in any SQLite viewer or programming interface. Here we are viewing the SQLite database using the DB browser for SQLite, which is available at sqlitebrowser.org. The Combined PostView Database utility is available in the Utilities section of the Program Launcher in SACS Executive version 13.0 and later. Select the PostView databases to be combined in the Analysis Results folder section. A task name may be assigned which can help distinguish analyses in the combined database. Select the location where the combined database will be saved in the target folder section. Then, click Merge Folders to combine the databases. Detailed output of the combination will be printed in the window below. Once the combined database settings have been created, they can be saved for later runs using File, Save Run File. These combined database settings can then be reloaded using File, Load Run File. Here is an example of a Combined Results Database settings file. Each component database requires a task name and a DB path. The task name will be used in the PostView database for reporting. Following the component database input, the combined database path is entered, preceded by an ampersand. This Combined Results Database settings file, as we saw before, can be generated by the Combined Results Database utility or can be generated manually using a text file editor. The SACS analysis can now be run from the command line or any programming language which can execute command line processes with analysisengine.exe with the run file path and the SACS installation directory path. The SACS combined databases can also be generated from the command line using the following command: merge results databases.exe with the Combined Results Database settings file path. Keep in mind that you may need to use absolute paths for the exe locations, which are in the SACS installation directory. You can also try adding a SACS installation path to the path environmental variable in Windows settings. The Combined Results Database contains a copy of each component database and a SQLite database. The combined SQLite database can be accessed just like the component analysis SQLite database. Here we have an example of a combined PostView database opened in Windows Explorer. When viewing the combined PostView database in Precede, users may switch between the component models using the Current Task drop-down menu. The results will reflect the current model being viewed. To view the critical results for the combined database, select the Combined DB task in the Labeling Options dialog. The critical task will be shown alongside the results label. It is recommended that the current task be a model which contains all of the elements, as the results will only be displayed for the visible elements. Now let's take a look at the combined results database in action. I'm going to open up this utility here, Combine Post-View Databases. And today we're just going to be combining 3 sample file databases that I've slightly edited to add the SQLite database and also make sure that all of them are generating post-view databases. So we're going to click Add Folder, and then I'm going to navigate to the location where my combined post-view database input is. Select the first sample 1DB and click OK. Now for the task name, this is going to be called Topsides. We can check name availability. This is only if you want to make sure that you don't have duplicates, because each one has to have a unique name. Then we'll go select sample 2. That's the in-place analysis, so I'm going to call that in-place. And then we will add sample 9DB, which is the toe analysis. We need to then select a target folder. So this will be in this combined folder here. And then we'll click Merge Folders. We can see that the database merge was successful and that the destination folder has been added. And here we have the combined post-view database. We're going to double-click that to open that in Pre-Seed. If anything did not go right when the combined post-view database was created, you'll get an error message when it opens saying that it's not a valid post-view database. So this one was created correctly. Here you can see that we switch between the in-place, the top sides, and the toe models. If I go to the labeling options, I can view the max combined unity check for the toe analysis independently, as well as go review and redesign individual members. So here I'm going to look at this member. For the critical condition is the roll plus heave. However, what I want to do now is look at the combined post-view database for all of the results. So to do that, I'm going to go back to Display, Labeling Options, select Max Combined Unity Check, but now I'm going to do the combined database. And as I said in the presentation, we want to make sure that we have all of the elements visible. In this particular view, we can't see the top sides, so we really can't look at that part of the analysis. So before I do the display, I need to make sure to switch back to my combined view, if you will. Now let's go back, click on Labeling Options, select the Max Combined Unity Check, and select the Combined DB. Now if we scroll in a little bit closer, we can see that certain UCs will have toe or in place for the jacket, depending on which is controlling. So in this particular instance, looks like most of the members are being controlled by the toe case, except for some of the diagonals and legs. Then if I scroll in up on the top sides, we can see that either the in-place or top sides load combination will be controlling for these elements. And if I want to go look at one of the members, this is going to be using the in-place view right now. So if I say see one of the elements that's being controlled by the top sides, if I see this, it's going to show the in-place analysis. So what I first need to do is go switch back to top sides and then review the member there. And so then we can do our redesign based upon that. But that's a little indication of how you can use this to see what members are critical and then redesign based upon that information. Thank you for your time. If you have any questions regarding this webinar, please reach out to myself and our team of Bentley experts on the Bentley Communities Forum listed on the web page for this webinar, or visit our forum on communities.bentley.com. Goodbye.